Before a single piece of steel could be lifted into the sky, before the first truck arrived on site, and before the first foundation was poured, engineers faced a daunting question. How do you build a bridge across a canyon that seems impossible to cross? Deep within the rugged mountains of Guizhou Province, China, lies the Huajiang Grand Canyon, a breathtaking landscape carved by nature over millions of years. Towering cliffs rise dramatically from the valley floor, while dense clouds often drift through the canyon, creating a scene that feels more like a fantasy world than a real location. Beautiful for tourists, a nightmare for engineers. For years, local communities on opposite sides of the canyon remained separated by geography. Although the straight-line distance between them was relatively short, traveling from one side to the other required a long and difficult journey through winding mountain roads. A trip that should have taken minutes often took more than 2 hours. As economic development in the region accelerated, the need for a faster connection became increasingly important. Businesses needed efficient transportation routes. Residents needed easier access to schools, hospitals, and jobs. Tourism was growing rapidly, and existing roads could no longer meet future demands. The solution seemed obvious: build a bridge. But there was one major problem. This was no ordinary canyon. The immense depth of the Huajiang Grand Canyon made conventional bridge construction nearly impossible. Engineers couldn't simply build support columns from the bottom. The terrain was too steep, too remote, and too dangerous. If a bridge was going to be built here, it would need to span an enormous distance without relying on supports in the middle. That requirement led engineers toward one of the most challenging designs in civil engineering: a suspension bridge. But even with the design selected, another challenge remained: finding the perfect location. The stability of a suspension bridge depends heavily on the strength of the mountains that support it. Every cable, every tower, and every anchor point would transfer enormous forces into the surrounding rock. If the geology wasn't strong enough, the entire project could be compromised. To solve this problem, teams of engineers, surveyors, and geologists began an extensive investigation of the canyon. Advanced drones were deployed high above the cliffs. Flying back and forth across the canyon, these unmanned aircraft collected millions of data points. Using laser scanning technology, they created highly detailed three-dimensional maps of the landscape. Every ridge, every slope, every crack in the rock, nothing was left to chance. Meanwhile, geological teams climbed dangerous cliff faces to collect rock samples from multiple locations. These samples were transported to laboratories where scientists analyzed their strength, density, and long-term stability. The goal was simple: find the strongest possible locations to support the future bridge. As data poured in, powerful computer systems began creating digital models of the entire canyon. Engineers simulated everything: extreme winds, heavy traffic, earthquakes, temperature changes, even the effects of decades of wear and tear. Thousands of virtual tests were performed before construction plans were finalized. Every potential weakness had to be identified. Every risk had to be reduced, because once construction began, mistakes would be incredibly expensive and potentially deadly. Months of analysis eventually revealed the ideal crossing point. The location offered the perfect combination of geological strength, structural efficiency, and transportation benefits. The bridge alignment was approved. The dream was becoming reality. But approving the design was only the beginning. Now, the real challenge could begin. Engineers needed to bring heavy machinery to the edge of one of the deepest canyons in China. Temporary access roads were carved into the mountainsides. Excavators cut through rock. Bulldozers cleared pathways. Truck after truck delivered equipment into the remote construction zone. The mountains echoed with the sounds of engines and machinery. Nature's silence was being replaced by the noise of progress. Survey crews carefully marked the exact center line of the future bridge. Every measurement had to be precise. Even a tiny error at this stage could create major alignment problems later in construction. Using GPS systems and laser-guided instruments, engineers established reference points across both sides of the canyon. These markers would guide every future step of the project. The schedule was officially underway. The countdown had begun. On one side of the canyon, workers prepared for foundation excavation. On the opposite side, teams organized materials and equipment for the massive tasks ahead. Thousands of workers would eventually contribute to the project, each one playing a small role in a much larger vision. The objective was clear: transform a 2-hour journey into a 2-minute crossing. Connect communities, boost economic growth, create a new landmark for the world. Yet standing at the edge of the canyon, it was difficult to imagine such a structure ever existing. There was nothing but empty space between the cliffs. No towers, no cables, no roadway. Just a vast natural divide. But every engineering wonder begins the same way, with an idea, and with the determination to turn that idea into reality. The planning phase was complete. The location was chosen. The designs were approved. The equipment was in place. Now it was time to build the foundations that would support the world's highest bridge. And that meant digging deep into the mountains themselves. Every great bridge begins with a foundation. Not the towers, not the cables, not the roadway suspended high above the ground. The true strength of a suspension bridge starts deep inside the earth, hidden beneath thousands of tons of concrete and steel. For the Huajiang Grand Canyon Bridge, the foundations would need to withstand forces unlike anything the region had ever experienced. Once completed, the bridge's main cables would constantly pull against the mountains with tremendous force. Every vehicle crossing the bridge, every gust of wind, and every change in temperature would generate additional stress throughout the structure. Without an incredibly strong foundation, the entire bridge could be at risk. Engineers understood that success or failure would be decided long before the towers rose into the sky. As construction crews arrived at the site, massive excavation equipment immediately went to work. The mountainsides that had stood untouched for centuries were about to be transformed. Bulldozers pushed aside loose soil. Rock breakers hammered relentlessly against solid limestone. Excavators clawed into the earth, removing thousands of cubic meters of material. Day after day, night after night, the sound of machinery echoed across the canyon. This was not simply digging. It was the creation of the bridge's backbone. The first major objective was constructing the massive gravity anchors. These enormous concrete structures would eventually hold the ends of the bridge's main suspension cables. To understand their importance, imagine 2 giant hands pulling on opposite ends of a rope. The harder the pull, the stronger the grip must be. The gravity anchors would serve as that grip, and they needed to be powerful enough to resist the force of the entire bridge. Engineers excavated deep into the mountains, creating enormous cavities capable of housing the anchor blocks.